Arithmetic series. We've looked in the last lesson at arithmetic sequence, which is this first list that I have here. This is a sequence. And it's an arithmetic sequence because I am continually increasing by the same number each time. Now, if I were to take those same numbers, the same list, and now add them together to find their sum, then this becomes a series. Okay, so sequence means that it's a list, and series means that it's a sum. So an arithmetic series can be added together, by just doing like this one, 1 plus 2 plus 3 plus 4 plus 5, but this series only has 5 terms. What if it's a series with a lot more terms? Maybe we can find an easier way to do it. So a long time ago, there was a teacher who posed this question to his students, and maybe it was just to get a little break because he figured this will take him forever. The instructions were to add up all the numbers between 1 and 100. And much to his dismay, there was a young student by the name of Carl Friedrich Gauss who got the answer in a matter of minutes. Probably, maybe even 1 minute, I don't know, but it was a very quick response to a question that he expected to take a very long time. So let's see if we can take a look at what Gauss did to figure this out as a young child and get this sum so quickly. He listed the numbers, or at least he started to list the numbers, from 1 to 100 with plus signs in between. Here's our series. And he noticed a pattern in the numbers. So he took the first one and the last one and added those numbers together to get 101. But then he noticed that he could take the second number and the second to last number, and that's also 101. And he kept going. The third number and the third to last number, also 101. Each time he would take a pair and move from the outside inward, he would get a sum of 101. Since he has 100 numbers in his list, in his series, that would be 50 pairs of 101. So then all young Gauss had to do was multiply 50 times 101. And that's how he got his answer so quickly of 5,050. Turns out that this pattern works for any arithmetic series. So we're going to write this, what we found, the number of pairs times the sum of the first and last, in something called summation notation. So for summation notation, I'm just going to clear some of this away. Actually, no, I'll just write it off to the side. Summation notation is a symbol, uses a sigma symbol, which you've probably seen before in maybe nerdy math movies or something, or Big Bang Theory, something like that. And it looks like this. And this symbol means that we're adding. And the numbers that we're adding are, we're going to start with the first number, and we're going to go all the way up until whatever number they tell us. So from 1 to any given number n. And if we want to add all of the numbers, let's say in this series, a of n, then the way that we're going to do it is by finding how many pairs of numbers I have. So to find our pairs, we have to take the total number of terms and divide by 2, just like we did here. We had 100 terms, and we divided that 100 by 2 to figure out how many pairs we had. And then we multiplied that by our 50 pairs got multiplied by 101 because that's the sum of each pair. So in this case, we're not going to write 101 because this is just general. We're going to say the first term plus the last term. So the sum all the way up to a sub n, that's what this says. The sum all the way up to a sub n, starting from 1 going to that nth term. To get that sum, I have to divide the number of terms by 2 to figure out how many pairs, and I have to multiply that by the sum of each pair. Okay, the seats in a local theater are arranged so that each row has 2 more seats than the row in front of it. We looked at this problem when we were looking at sequences, but now we're going to be asked to find the total number of seats. So there are 4 seats in the first row. How many total seats are in all 12 rows? Well, in order to use our arithmetic series formula, we need to know the first term, we need to know the last term. In this case, it'll be, let me just fill that in, it'll be 12, right, because we have 12 rows. And we need to know how many, which that's easy. Our n is 12. There's 12 terms, 12 rows. So we already know the first term. We don't know the 12th term. So that's the first thing that we have to find. So we're going to use the sequence formula. That's this one. First term plus the common difference, right? And we're going to do that for a of 12. So the first term is 4. Each row has 2 more seats than the row in front of it. So that common difference is going to be 2, because I'm going to be adding 2 each time. And for a total of 12 rows. So 12 minus 1. That will give us 4 plus 2 times 11, which is 4 plus 22, which is 26. So now we have this information as well. So this is our A of 12, or A sub 12, our 12th row. So now let's do the summation. We're finding the sum from the first row to the 12th row of this series. And here's the general form. I have to find my number of pairs first, and then I add the first and last. So when we fill that in, we have 12 rows, so 12 numbers in our list, which would give us 12 over 2 here. And then the first row has 4 seats, and the last row has 26. So that's going to be 12 divided by 2 is going to be 6 times 30, which will give us 180 seats in this small local theater. All right, one more. I saved the best for last. Emma started a savings account by depositing $27. Each month, she deposits more money than the month before. At the end of 24 months, she has saved $1,476. How much more does she, this should say she. How much more does she deposit each month? Well, this one's tricky. We have our first term. We have n, because it's 24 months, which means we'll have 24 numbers in our list if we list the amount she deposits each month. And this time we have what the sum is. We have what the series equals. So for our summation, from 1 to 24 of A of 24, we know that that's equal to 1,476 because it tells us when she, at the end of the 24 months, she saved this much money. So that means adding all of the months up to 24, we get this much. So in our formula, we're going to replace this part of the formula with what the sum is. So we're going to have 1,476 is equal to, and then here's the rest of our formula that we've looked at a bunch of times now. And we have n, like we already determined. We have n, it's 24. We have a1, which is 27. So this is the number that we're missing this time. So let's solve for it. Let's plug everything in. 1,476 equals 24 over 2, and then 27 plus, and what we're looking for is the final month, which is A of 24. We know that the sum up to the final month is this, but we want to know what that last term is. All right, so now we're just solving equations. Yay! All right, so the 24 becomes a 12. And then in order to solve this, we need to get the parentheses alone. So we have to get rid of this times 12 out front. So we divide both sides by 12. Let me do that quickly. 1476 divided by 12 is 123. Okay, so now we have that that is equal to 27 plus the 24th term. And subtract 27 from both sides. You probably saw that step. I didn't need to tell you that one. And we get that the 24th term is 96. Okay, so now we have our first term, we have n, we have the sum, and we have the last term. But what we're asked here is how much more does she deposit each month? So, in other words, if she starts at 27, and then she's depositing more and more and more and more, and that final month is 96, how much more is she adding? Like, what's the common difference? What's the increase here from term to term? That's what we're being asked to find. So we can use the formula that we use for sequences with the common difference and plug everything else in. So that formula, one that we've used a few times in this lesson, but it's really from the previous lesson, looks like this. And we can fill in everything and then solve for D. So our final term is 96. Our first term is 27. We don't know D. We know that we have 24 minus 1 terms. So we have 96 equals 27 plus 23D. Because I did 24 minus 1 is 23, multiplied by D, 23D. So now this is just a two-step equation. To solve this equation, we're going to have to subtract 27 from both sides, and then divide both sides by 23. So do that. I'll give you a minute. I'm going to do it as well. And you should have gotten that D equals 3. This is our final answer. This is the one we're looking for. How much more does she deposit each month? $3 more. So 27, and then 30, and then 33, and then 36. You get the idea, all the way up to 96. So this was a tricky one because we had to use both formulas and we had to work backwards to find a missing piece for each one.